April 18th, 1943. Solomon Islands. 9:34 a.m. Two Betty bombers cruise at 6,000 feet. Inside, Admiral Isoroku Yamamoto reviews invasion plans. Japanese fighters weave protective patterns above. Standard procedure. Routine flight. 400 miles away, 16 P-38s had launched at 07:25. Their nose-mounted guns needed no convergence adjustment. No sweet spot at 250 yards like other fighters. These lightnings could kill accurately at 600 yards. Beyond the Merch, beyond where dogfights began, the Japanese pilots expected close combat, turning battles at 200 yards. Their training emphasized agility over distance. They never knew American guns could reach past the Merch, past where reflexes mattered, past where skill decided outcomes. In 11 minutes, geometry would defeat experience. Industrial design would trump samurai tradition. A specification from 1939 would change history. This is that story. September 20th, 1939. Burbank, California. Lockheed's drafting room. Engineers cluster around specification tables. The Army Air Corps wanted a twin-engine interceptor. 360 miles per hour. Ceiling of 20,000 feet. Standard requirements. But Kelly Johnson's team made an unusual choice. They mounted all guns in the central pod. One 20mm cannon. 4 50 caliber machine guns. All firing straight ahead. No convergence needed. The trajectories came together between 350 and 400 yards. The ballistics report noted. Vertically harmonized only. Horizontally, they flew parallel forever. Standard fighters mounted guns in wings. Physics demanded convergence. Bullets had to angle inward to meet at a specific distance. 250 yards for most American fighters. 300 for early British Spitfires. A narrow killing zone. Missed that sweet spot? Bullets spread uselessly wide. Too close? They hadn't converged yet. Too far? They'd already separated. Wing-gun fighters lived or died by distance judgment. The P-38 ignored this problem. Centerline mounting meant parallel trajectories. Effective fire from point-blank to 600 yards. The training manual would later state, effective straight-ahead range of more than 600 yards. Lieutenant Ben Kelsey reviewed the specifications. He'd pushed for this interceptor design. Speed and climb rate dominated his requirements. The nose gun arrangement seemed secondary, a quirk of twin-boom architecture. Lockheed received purchase order number 40. The prototype wasn't even finished. No combat testing. No tactical doctrine. Just drawings and calculations. By December, wind tunnel tests confirmed aerodynamic stability. The concentrated weight in the nose actually improved handling. Gun heating wouldn't affect wing surfaces. Maintenance crews could access all weapons from one location. Production blueprints specified the layout. Weapons bay 7 feet long. All barrels within 18 inches of centerline. Ammunition feeds from behind the pilot. 900 pounds of concentrated firepower. The Army approved full production. They wanted 400 aircraft. Nobody discussed the tactical implications. Nobody realized they'd eliminated the convergence problem that plagued every other fighter design. This geometric accident would matter in 3 years. When American pilots faced Japanese veterans over the Solomons. When every yard of engagement distance meant survival. 1942. Army Air Forces training bases across America. Instructors spread harmonization charts on classroom tables. Standard doctrine for P-40 fighters. Convergence at 250 yards. P-47 Thunderbolts, 300 yards. Curtiss P-40, 275 yards. Then came the Lightning Manual. No convergence diagram, just straight lines extending from the nose. Effective straight-ahead range of more than 600 yards. Instructors paused at this specification. Captain Robert DeHaven taught gunnery at Muroc. He'd flown P-36s and P-40s. Both demanded precise distance judgment. Get inside 200 yards, score kills. Stay outside 300, waste ammunition. The lightning changes everything, he told his students. You can fire at 600 yards and still hit. No convergence means no guesswork. The Army Air Force's Manual 200-1 stated, harmonization data is based on the best available angle of attack calculations. Every fighter required complex trigonometry, except the P-38. Students practiced on boresight ranges. Wing gun fighters needed careful adjustment. Armorers spent hours aligning each gun. Temperature changes threw off convergence. Combat damage meant reharmonization. P-38 armorers had simpler jobs. Vertical alignment only. Check bore straightness. Verify parallel mounting. The guns shot where they pointed. Always. Lieutenant Richard Bong arrived at Hamilton Field, fresh from advanced training. He'd qualified on P-38s in September. His instructors noted exceptional gunnery scores. Most pilots need 50 hours to judge convergence distance, his report stated. Bong hits consistently from his first flight. The reason was geometry. No convergence calculation required. See target, point nose, fire. The simplicity masked revolutionary advantage. Training films showed combat footage from Eagle Squadron Spitfires. British pilots pressed to 150 yards before firing. They'd learned that convergence at 400 yards wasted ammunition. The RAF had officially reduced harmonization from 400 to 250 yards. Meanwhile, Lightning pilots practiced long-range shooting. For 100 yards, 500, 600, the bullets stayed grouped. The 20th millimeter cannon and 50 calibers shared similar trajectories out to maximum range. Intelligence reports from the Pacific described Japanese tactics. Close-in fighting. Agile turns at 200 yards. The Zero's extraordinary maneuverability dominated at knife-fighting range. American doctrine evolved differently. If the Lightning could kill at 600 yards, why close to 200? Late 1942. Henderson Field, Guadalcanal. The first P-38 squadrons arrived in theater. The 39th Fighter Squadron. The 70th. Pilots who'd never seen combat. Ground crews working in mud and humidity. Japanese pilots controlled the sky. Their Zeros turned inside any American fighter. They'd perfected deflection shooting at close range. Years of combat over China taught them to close within 100 yards. Major John Mitchell led the 39th Squadron's first patrol. For Lightnings at 18,000 feet. Radar reported incoming Japanese formation. 20 Zeros escorting 18 Betty bombers. Standard tactics would mean diving through the escorts, one pass at the bombers, then running. The Zeros would chase, forcing a turning fight. American pilots usually lost those engagements. But Mitchell remembered his training. Effective straight-ahead range of more than 600 yards. Why merge at all? The Lightnings approached head-on. At 800 yards, the Zeros began their defensive turns. At 600 yards, Mitchell fired. 1 second burst. The leading Zero exploded. The Japanese scattered. They'd never experienced accurate fire at that range. Their own wing guns converged at 200 yards. They needed to close another 400 yards to fight back. Lieutenant Rex Barber scored next. High side approach. 500 yards. His nose battery sparked along a Zero's fuselage. The enemy pilot never got within his own range. After action reports reached 5th Air Force Headquarters. General George Kenney read with interest. For Lightnings had engaged 20 Zeros. 2 confirmed kills. 0 American losses. They never got close enough to use their maneuverability, Mitchell reported. We controlled engagement distance. The intelligence section analyzed Japanese equipment. The Zero's Type 99 cannon converged at 200 meters. Roughly 220 yards. The Type 97 machine guns crossed at the same point. Japanese training emphasized one plane, one shot, close to point-blank range. Use the Zero's agility to achieve perfect position. Fire once for a certain kill. This philosophy assumed the enemy needed similar positioning. That Americans would also close to 200 yards. That dogfights happened in phone booth dimensions. The 39th Squadron developed new tactics. Slashing attacks from above. High-speed passes. Never slow down. Never turn with zeros. Use the lightning speed and nose guns to control distance. By December, the kill ratio shifted. Lightnings claimed 3 Japanese for every loss. The geometry of guns had changed the geometry of combat. December 1942 through March 1943. From Buna to the Bismarck Sea. The Lightning squadrons refined their distance advantage. Mission boards showed increasing tallies. The 347th Fighter Group joined operations. Fresh pilots, new aircraft, same nose-gun geometry. Lieutenant Richard Bong transferred to the 475th Fighter Group. His first combat mission, escort B-24s to La. 40 Zeros intercepted. Bong ignored conventional ACM. No barrel rolls. No scissors. Just high-speed slashing passes. He opened fire at 550 yards. A Zero disintegrated. The pilot never saw him coming. Bong credited with 40 Japanese aircraft. The final tallies would show. But in early 1943, he was still learning. Learning that distance equaled safety. Japanese after-action reports, captured later, expressed confusion. Enemy fighters engage beyond normal range. Our pilots cannot close to effective distance. Losses mounting. The Imperial Navy's training manual specified convergence at 190 meters. Even closer than the Army's Zeros. Their pilots practiced at ranges where they could see enemy pilots' faces. Meanwhile, American production delivered improved P-38G models. Same nose configuration, better turbochargers, improved cockpit heating. The gun arrangement never changed. 120mm for 50s, all pointing straight ahead. March 2, 1943. The Battle of the Bismarck Sea. 8 Japanese transports headed for La. 55 Zero escorts flying cover. The largest convoy operation since Guadalcanal. They expected standard attacks. B-17 bombing from altitude. Easy to evade. Instead, modified B-25s came in at mast height. And above them, 60 P-38s controlled the air. Not dogfighting. Not turning. Just slashing through Japanese formations at 400 miles per hour. Captain Thomas Lynch demonstrated the tactic. Dive from 20,000 feet. Fire at 600 yards. Zoom climb before Zeros could react. Repeat. The Japanese lost 8 transports. All 8, plus 12 of 55 fighters. The Lightnings lost 1 aircraft to mechanical failure. Not one fell to enemy guns. General Kenny wrote, "The P-38's nose concentration gives us standoff capability. We can hit them before they hit us." Technical analysis confirmed the advantage. At 600 yards, the Lightning's 50 caliber bullets retained 80% of muzzle energy. The 20mm shells still flew flat. Convergence wasn't spreading the pattern. A captured Zero underwent firing tests. At 600 yards, its pattern spread 12 feet wide. Useless dispersion. The Lightning's pattern at the same distance, 30 inches. April 18, 1943. The longest fighter intercept of the war. Admiral Yamamoto's itinerary reached American intelligence. Detailed schedule. Exact timing. He'd inspect bases near Bougainville. 2 Betty bombers, 6 Zero escorts. The mission required 400-mile overwater navigation. Only Lightnings had the range. Auxiliary tanks gave them 900 miles total. No other Allied fighter could attempt it. Major John Mitchell planned the intercept. 16 P-38s from the 339th Squadron. 4 designated shooters. 12 flying cover. Launch from Henderson at 0725. They flew at wavetop height. Dead reckoning navigation. No radio contact. Mitchell calculated they'd need 2 hours 15 minutes to reach the intercept point. The specially fitted P-38s took off beginning at 0725. The official record stated 165-gallon belly tanks, 330-gallon wing tanks, maximum fuel load. But fuel was only half the equation. They needed to engage quickly. No extended dogfight. The Lightnings would have 5 minutes over target before fuel-forced withdrawal. At 09:34, they spotted the Japanese formation, exactly where predicted. 2 Bettys at 6,000 feet, Zeros weaving above. Lieutenant Rex Barber led the attack element. He dropped tanks and climbed. The Zeros saw him and turned to engage. Standard tactic, force a turning fight. Barber ignored them, nose on the lead Betty. At 600 yards, he fired. The concentrated nose battery walked hits along the bomber's wing route. Fire erupted. The Betty rolled and dove into the jungle. Lieutenant Thomas Lanfear engaged the second bomber. Same tactic. Ignore the Zeros. Use the range advantage. His fire shattered the Betty's tail, crashed into the sea. The Zeros tried to pursue, but the Lightnings were already diving away. For 100 miles per hour, the mission clock showed 4 minutes elapsed. Yamamoto died in the jungle crash. Japan's most brilliant naval strategist. Killed by guns that shot straight ahead. By a geometry lesson from 1939. The longest-distance fighter intercept mission of the war, historians noted. But distance meant more than just range. It meant engagement space, fighting room, the ability to kill before the merge. No other Allied fighter could have executed this mission. British Spitfires lacked range. Navy Corsairs couldn't navigate precisely enough. Army Thunderbolts burned too much fuel. Only the Lightning combined 3 elements: range to reach the target, speed to escape, and nose guns that killed at standoff distance. Yamamoto's death proved all 3 mattered equally. Japanese morale collapsed. Their best admiral killed by American planning and technology. By fighters that wouldn't engage in samurai-style combat. 1943. Training fields and forward bases. Armorers compared notes across fighter types. P-40 Warhawks needed constant convergence adjustment. Rough landings through off-wing alignment. Combat damage meant complete reharmonization. The RAF published new specifications, reducing harmonization range from 400 to 250 yards. Their journal stated, years of combat experience compressed into one specification change. British pilots had learned through losses. At 400 yards, convergence spread bullets too wide. 1 gun might hit while 5 missed. They needed concentration, not coverage. Hurricane squadrons adopted the new standard. Spitfire wings got similar treatment. Typhoon pilots requested even closer convergence, 200 yards. The trend was clear. Tighter patterns meant more kills. Meanwhile, Lightning squadrons maintained their simple setup. No convergence at all. Infinite parallel lines. The boresight procedure took 30 minutes versus 3 hours for winggun fighters. Captain Charles MacDonald commanded the 475th Fighter Group Squadron. He studied comparative gunnery tables. At 200 yards, all fighters were lethal. At 400 yards, only the Lightning maintained tight groups. Which approach saves pilots and fuel in the Pacific? He asked his intelligence officer. The answer came from loss statistics. Winggun fighters suffered 3 times the casualties in similar engagements. They had to close inside 300 yards, inside the Zero's performance envelope. Lightnings could engage and disengage at will. Their pilots chose the range. 600 yards or 60. The nose guns remained effective throughout. Technical reports documented ammunition dispersion. 50 caliber rounds from wing guns showed a circular error probable of 6 feet at 400 yards. From nose mounts, 18 inches. The 20mm cannon showed similar advantages. Wing-mounted Hispanos suffered from vibration. G-forces affected trajectory. The Lightning's nose cannon sat on the aircraft's centerline. Minimal stress, maximum accuracy. New pilots arrived weekly. They trained on various fighters before assignment. Unanimous feedback. The Lightning was easier to shoot with. No mental math required, reported Lieutenant Thomas McGuire. See the target, fire. The bullets go where you point. McGuire would eventually score 38 victories. All in Lightnings. All using the same principle. Engage at maximum range, disengage before the merge. The Japanese adapted slowly. They extended their convergence to 250 yards, still half the Lightning's effective range. They tried head-on passes, but approaching Lightnings meant flying into concentrated fire. By mid-1943, the tactical advantage was undeniable. Nose guns meant distance. Distance meant survival. Mid-1943, Southwest Pacific Theater. The 475th Fighter Group's tally board showed remarkable numbers. In 6 months, 150 confirmed kills, 12 losses, the best ratio in theater. Major Thomas McGuire developed his shooting technique. No deflection calculation, no lead computation. Just point the nose ahead of the target's flight path and fire. Let the enemy fly through the stream. McGuire scored 38 aerial victories, second only to Bong's 40, the records showed. Both flew exclusively Lightnings. Both used the same method, long-range engagement. Other aces flew different fighters. Navy pilots in Corsairs, Marine pilots in Wildcats. Their scores grew slowly. They had to work harder for each kill, close to convergence range, inside the enemy's envelope. Dick Bong refined his approach further. He discovered that at 400 yards, he could fire 3-second bursts without overheating. Winggun fighters managed 1 second before dispersion ruined accuracy. The concentrated nose battery created another advantage. Psychological effect. Enemy pilots saw all tracers coming from one point, a solid stream of death. Wing guns produced scattered tracers, less intimidating, less focused. Japanese tactical doctrine began acknowledging the problem. Captured documents mentioned Lightning advantage beyond normal combat range. They recommended avoiding head-on engagement. But what else could they do? The Zero's strength was maneuverability, turning radius, roll rate, all useless beyond 300 yards. The Lightning negated every Japanese advantage by refusing close combat. 5th Air Force compiled statistics. Lightnings flew 25% of fighter missions. They scored 40% of aerial victories. The math was clear. Nose guns multiplied combat effectiveness. General Kenny requested more Lightnings. "Send everyone you can spare," he cabled Arnold. There were 3 conventional fighters out here. Production increased. Lockheed's Burbank plant assembled 40 aircraft weekly. Each carried the same armament. 120mm for 50s all in the nose. Mission profiles expanded. Long-range escort, fighter sweeps, ground attack. The nose guns excelled at everything. Strafing required no convergence adjustment. Bomber interception benefited from concentrated firepower. The 475th developed a motto, "Satan's angels but technology, not mythology," gave them their edge. Simple geometry, parallel trajectories, 600-yard effectiveness. By August 1943, Japanese pilots avoided Lightnings when possible. They'd engage Corsairs, challenge Warhawks, but those twin-boom silhouettes meant standoff death. The top 2 American aces both flew Lightnings. This wasn't coincidence. It was mathematics. More engagement opportunities, higher survival rates. The nose gun configuration multiplied both factors. August 1943 through early 1944, from the J model to the J-25. Lockheed refined the Lightning continuously. New nacelles reduced drag. Improved intercoolers increased power. Hydraulically boosted ailerons improved roll rate. But the nose guns never changed. The geometry remained constant. The critical addition came with dive recovery flaps. P-38L and late P-38J models equipped with electrically operated dive recovery flaps. The manual stated, these prevented compression lock in high-speed dives. Now Lightnings could attack from any altitude. Dive at 500 miles per hour. Fire at 600 yards. Deploy flaps and recover. The Zero couldn't follow that profile. Lieutenant Colonel Charles Lindbergh arrived in the Pacific. Officially a civilian technical representative. Unofficially teaching combat techniques. He'd studied the Lightning exhaustively. Lindbergh demonstrated fuel management. Lean mixture, low RPM cruise. He extended range to 11 hours. 11 hours meant 1,000-mile combat radius, with nose guns effective at standoff range. "You don't need to dogfight," he told squadron pilots. "Use your advantages: speed, range, and concentrated firepower." He flew combat missions despite regulations. On July 28, he engaged a Ki-51 at 800 yards. Long burst. The Japanese aircraft disintegrated. Lindbergh never got within the enemy's range. Production specifications evolved. The L model incorporated all improvements. 2 300-gallon drop tanks became standard. Combat radius exceeded 600 miles. No other fighter matched it. The nose armament received minor updates. Feed mechanisms improved. Heating elements prevented frozen guns at altitude. But the basic geometry stayed identical. 120 for 50s, all pointing straight. Japanese aircraft designers studied captured lightnings. They understood the advantage. But their philosophy prevented copying. Japanese tradition emphasized skill over technology. Spiritual strength over mechanical advantage. The new Frank and George fighters mounted heavier armament, but still in wings, still requiring convergence. They could match lightning firepower but not its accuracy at range. American doctrine fully embraced standoff engagement. Training manuals emphasized, never turn with a zero. Use your speed and range advantage. The statistics proved the concept. By early 1944, Lightning squadrons averaged 4-to-1 kill ratios. Some units reached 6-to-1. The nose gun advantage compounded with pilot experience. New pilots needed less training. The learning curve was shorter. Point and shoot worked at any range inside 600 yards. Winggun pilots needed months to develop range estimation skills. The airframe had finally caught up to its gunnery potential. Dive flaps, boosted controls, and extended range, all supporting the original nose gun configuration. The 1939 geometry choice had become doctrine. Mid-1944, the Pacific Air War at maximum intensity. Maps in 5th Air Force headquarters showed lightning coverage. Overlapping circles of 900-mile radius. From New Guinea to the Philippines. Every Japanese base under threat. The enemy expected merges to start close. 300 yards maximum. Their newest pilots trained for 200-yard engagement. Get close, turn hard, fire once. Lightning pilots delivered accurate fire at twice that distance. Head-on passes at 600 yards. Beam attacks at 500. Diving attacks from 3,000 feet above. Standard ammunition loads supported extended engagement. 300 to 500 rounds for each machine gun. 150 rounds for the cannon. The manual specified exact quantities. This meant 40 seconds of 50 caliber fire. 15 seconds of 20 millimeter. Enough for multiple passes. Multiple angles. Winggun fighters carried similar amounts but wasted half to convergence spread. Lieutenant Colonel Tommy Lynch demonstrated the mathematics. For passes per mission, 3-second bursts, all shots inside 600 yards. He averaged 1 kill per sortie through 1944. The logistics multiplied effectiveness. Each Lightning could engage 6 to 8 times per mission. Fuel for 2-hour combat loiter. Ammunition for extended engagement. All delivered through nose guns that never needed convergence. Japanese losses mounted beyond replacement capacity. They lost experienced pilots faster than training programs could graduate novices. The American standoff advantage accelerated this attrition. A captured Japanese training syllabus revealed the problem. 300 hours to produce a competent Zero pilot. 60 hours of that practicing deflection shooting. All assuming close-range combat. American Lightning pilots reached combat effectiveness in 150 hours. No deflection training needed. The nose guns simplified everything. Point, shoot, kill. By mid-1944, some Japanese squadrons operated at 30% strength. They couldn't replace losses. Each engagement cost them irreplaceable experience. The mathematics were relentless. If Lightnings could engage at 600 yards, and Zeros needed 300, Then Lightnings got first shot every time. First shot advantage meant fewer losses. Fewer losses meant experienced pilots survived. Sortie math favored platforms that hit early and left clean. No extended dogfights. No fuel-burning turn contests. Just high-speed passes at maximum range. The 20mm cannon proved especially effective. At 600 yards, it retained enough energy to penetrate armor, to ignite fuel tanks, to shatter engine blocks. 1944 through 1945, Burbank Factory and Pacific Depots. Production boards showed remarkable numbers. 10,000 Lightning airframes planned. Nearly 4,000 would be L models, the final, perfected version. Of the 10,038 P-38s built, 3,923 were P-38 LS, the records confirmed. Each carried the same nose armament. The geometry never changed. Assembly lines produced 40 aircraft weekly, then 50, then 60. Each shipped with two 300-gallon drop tanks standard. Combat radius now exceeded any Japanese fighter by threefold. The supply chain stretched across the Pacific. Crated Lightnings on Liberty ships, assembled at Australian depots, ferried to forward strips, a continuous pipeline of standoff capability. Japanese production couldn't compete. They built hundreds while America built thousands. But quantity alone didn't determine outcomes. The nose gun configuration multiplied each airframe's effectiveness. Consider the math. One Lightning could engage effectively at 600 yards. 1 0 needed 300 yards. Therefore, one Lightning equaled 2 zeros in standoff value. But the multiplication continued. Lightnings survived more missions. Pilots gained more experience. Experience improved accuracy. The advantage compounded exponentially. Depot maintenance proved simpler for nose-gun aircraft. Armorers could service all weapons from one position. No crawling through wings. No complex convergence procedures. A crew could rearm a Lightning in 12 minutes. The L model incorporated every lesson learned. Dive recovery flaps for high-speed attacks. Boosted ailerons for rapid roll. Improved turbochargers for altitude performance. All supporting the nose-gun philosophy. The final production version could carry two 300-gallon drop tanks. Specifications noted. 600 gallons external. 300 internal. 900 gallons total. Enough for 1,000-mile combat missions. At those ranges, only Lightnings could provide escort. Only nose guns could guarantee effectiveness. The geometry from 1939 had become the foundation of Pacific air strategy. Factory quality improved continuously. Tighter tolerances meant better accuracy. The nose guns, rigidly mounted, benefited most. Wing guns suffered from flex and vibration. Nose guns stayed true. Production peaked in early 1945. 70 Lightnings weekly. Each represented 40 Japanese aircraft destroyed over its service life. The mathematics of attrition. When factories scale, doctrine becomes infrastructure. Every squadron received Lightnings. Every pilot learned standoff engagement. Every mission extended American reach. The production lines ran 24 hours. 3 shifts. 7 days. Democracy's arsenal converting aluminum into air superiority. Each aircraft carrying Kelly Johnson's geometric solution. 1944 through 1945. From New Guinea to the Philippines. Reconnaissance F-5 Lightnings photographed every Japanese position. The same nose configuration minus guns plus cameras. They flew alone at 30,000 feet. Speed and altitude their only protection. Fighter-bomber Lightnings attacked ground targets. 500-pound bombs under each wing. Nose guns strafing ahead. The parallel trajectories walked perfectly down runways. Along ship decks. Through vehicle columns. Night fighter P-38M variants carried radar operators. Same nose guns. Engagement in total darkness. Radar vector to 600 yards. Fire. The geometry worked without visual contact. The versatility stemmed from the nose configuration. Every mission type benefited from straight-ahead firepower. No convergence compromise for different altitudes, different speeds, different targets. Japanese formations adapted their tactics. They flew wider spacing, defensive weaves, anything to avoid the lightning's nose. But wider formations meant less mutual support. The American advantage multiplied. Mission reports showed the pattern. Lightning approaches from 12 o'clock high. Japanese formation splits. Lightnings fire at maximum range. 1 or 2 Japanese fall. Lightnings extend away. Repeat. The Japanese couldn't counter this. Closing to their gun range meant flying through 600 yards of accurate fire. Their losses proved the impossibility. Nose guns meant one straight-ahead line of lethal fire, analysts noted. A line extending from point-blank to maximum range. No gaps, no sweet spots, just continuous lethality. Lieutenant Richard West described a typical engagement. 4 Zeros at 2 o'clock. Turned into them. Fired at 600. Lead 0 exploded. Fired at number 2 at 400. Heavy damage. Remaining 2 fled. The engagement lasted 30 seconds. West never got within 0 gun range. His survival depended on geometry, not skill. On parallel trajectories, not deflection shooting. Combat films confirmed the advantage. Tracers from lightning nose guns formed solid streams. Tight, focused, deadly. Winggun tracers scattered like shotgun patterns. Impressive but ineffective at range. The more distant the opening shot, the fewer losses to flak and fighters. Ground gunners needed time to track. Enemy fighters needed distance to close. 600 yards bought precious seconds. By early 1945, Lightning squadrons operated with near impunity. Japanese pilots had orders to avoid them when possible. Engage only with numerical superiority. Even then, losses mounted. The geometry lesson from 1939 had become Japan's nightmare. Every lightning represented 600 yards of denial, of American reach exceeding Japanese grasp. 1945, the war's final months. Lightning variants filled every role. Standard fighters escorted B-29s to Japan. F-5 reconnaissance models mapped invasion beaches. Night fighters protected fleet anchorages. All used the same fundamental nose configuration. The P-38 had been designed as an interceptor. High altitude, high speed, heavy armament. But the nose gun arrangement made it infinitely adaptable. Ground attack missions leveraged the parallel trajectories. Pilots could strafe accurately at longer ranges. No convergence point to consider. Railway engines exploded at 500 yards. Fuel dumps ignited at 600. The L model represented ultimate refinement. Every system optimized. Final production version, the record stated, 3,923 built, each incorporating every lesson learned. Late-war Japanese pilots faced an impossible equation. American quantity multiplied by quality. Thousands of lightnings, each effective at twice their range. Mathematics guaranteed defeat. The nose gun configuration had proven decisive. Not through revolutionary technology. Not through exotic materials. Simply through geometric efficiency.
Parallel beats convergent.
Training manuals from 1945 emphasized the principle. Straight-ahead effectiveness beyond 600 yards, a specification that rewrote Pacific air combat. The same geometry underwrote multiple mission sets: escort, interception, ground attack, reconnaissance, night fighting. One configuration, infinite applications. Design headroom plus centerline firepower equaled durable utility. The Lightning served from 1942 through 1949, longer than most World War II fighters. The nose guns remained effective throughout. Japan surrendered in August 1945. Lightning pilots had claimed over 1,800 aerial victories in the Pacific. The top 2 American aces flew Lightnings exclusively. The statistics told the story. But behind the numbers lay geometry. A decision in 1939 to mount all guns in the nose. To avoid convergence complications. To shoot where the pilot pointed. Post-war analysis. Archived manuals and unit records spread across the table. The evidence was overwhelming. Use-off training manuals credited effective straight-ahead range of more than 600 yards, the Lightning's defining advantage. RAF Historical Society Journal 45 documented the alternative approach. Reducing harmonization from 400 to 250 yards, years of combat experience compressed convergence. Made the sweet spot smaller but deadlier. Two philosophies, convergence versus centerline, close engagement versus standoff. Both worked, but in the Pacific's vast distances, standoff dominated. The numbers supported this. Lightning squadrons averaged 4-to-1 kill ratios. Some reached 6-to-1, the best of any American fighter type. Consider Operation Vengeance. April 18th, 1943. 400 miles each way. Precision timing. 2 bombers destroyed in 4 minutes. Yamamoto eliminated. Only Lightnings could execute that mission. Only nose guns could guarantee quick kills. The mission fused range planning with long-range accuracy, both stemming from the same design. Bong and McGuire, America's top aces, flew only Lightnings. 40 and 38 victories respectively. Both used the same tactic. Engage at maximum range. Disengage before the merge. The geometry protected them. 600 yards of effective fire. 300 yards beyond Japanese reach. Simple mathematics. Profound advantage. 10,038 Lightnings built, each carrying the same nose configuration. The geometry scaled into doctrine, into strategy, into victory. The Pacific Air War validated Kelly Johnson's choice. Nose mounting eliminated convergence problems, created standoff capability, simplified training, improved survival rates. In the Pacific, geometry plus logistics shifted the odds. Not pilot skill alone, not courage alone, but mathematical advantage multiplied across thousands of sorties. The Lightning proved that design decisions echo through history, that specifications from 1939 could determine outcomes in 1945, that geometry ultimately is destiny.